Hello friends, in this video we will solve this question. It's from net exam. We have to identify what were the products A in the first step, and then we have a second step. Here we are having the second step, and what will be the product B. We have options A, B, C and D, and various products are given in the form of A, B. So we will check which is the correct option. If we are observing for all the product A, it is the electrocyclic ring opening of the 4-membered ring. It's only 4-membered ring opening, so this bond will fall here, and this bond, this double bond, it falls here. So we will have to check how this group, the stereochemistry or the geometry of this, the group, where it goes outwards, or it goes outward inward, or whether it goes inward or it goes outward and inward. So we will have to check. So I will be using 1,3-butadiene. I will be using the HOMO-LUMO, the molecular orbital for the 1,3-butadiene. And remember the condition given, it is thermal. Thermal means it will be ground state HOMO. So if you remember from the previous video, you can check the links over here for the electrocyclic reactions, ring opening reactions. The HOMO for 1,3-butadiene in the ground state, it looks like this. We are concerned only about the end lobes, how the end lobes look. If one is on top and another end is at the positive phase, it is down. So the end phases, they look like this. So we'll be using only this part. Now let us consider how the reaction will proceed. So we are having a thermal condition. The HOMO, the end phases, as we know that it should be looking like this, one positive phase above and one phase down. Okay, when it opens up, it should look like this. Okay, now only considering the 1,3-butadiene part, we have the positive phases, they are in contact. Only when the same phase they come in contact, they will be forming a bond. This is very important. Only when the positive phases come in contact, only then they form a bond. Since it is already in the cyclic structure, so they are already in contact. The next information, it is this part, this CH3 group, it is above the plane of the paper. Above the plane of the paper means I can draw it upwards. When it is upwards, it means it is above the plane of the paper. Now regarding the stereochemistry over here, this part, the stereochemistry, it is down. Down means it will be, we have to show it downwards. This is CH3 group and this is the next CH3, and there is a double bond which I will be drawing it here. I will be ignoring this part at the moment since we don't need that at the moment. Okay, now let us understand how the ring opening take place. This part, it will fall here. This double bond, it falls here. Okay, only then it will be opening up. Now what happens? So since the bond is falling down, this bond has to break. Now once it breaks, remember this part has to go above and this part has to come down. This is very important because the HOMO of the 1,3-butadiene, it has to look like this. Since it has to look like this, one phase above, so one has to go on top and one has to go below. So how it opens up? This, if we consider this part, it goes above. So let me draw. So the positive part going on top. Since the positive part went on top, what will happen to this group? These groups come inwards. This group comes inside. Hope I am clear. Since this part we are rotating it in this anti-clockwise direction, this part comes in the inner way. Now what about this part? Since we need this positive phase below, So if I rotate it in the anti-clockwise direction again, so what will happen? I get positive phase down, and this group, since I'm rotating it in the anti-clockwise direction, again this group comes inward. So where are the double bond? The double bond is here. So both the CH3 group, they are inward. This is inward, I can say, inward. Now both the CH3 groups, they are inward. Another thing is that instead of this part, we can also have this positive phase here and this positive phase here. It can also look like this. We have positive phase here and positive phase here. It can also look like this. Both are same. Okay, so in order to look like this, another rotation that can happen, to get this down, I have to rotate this part in the clockwise direction. Once you do it in the clockwise direction, this part, it will come below. Okay, since you are rotating it in the clockwise, this group, if you rotate in the clockwise, it goes outward. It comes here. I am drawing the other part. Okay, now what happens to this? Again, I want it on top. We are considering this part, so I want the positive phase on top. To get this part on top, again I have to rotate it in the clockwise direction. Since I rotate it in the clockwise direction, this part goes on top and we get the positive phase here. What happens to this group? Since we are rotating it in the clockwise direction, it goes outward. So, and we get the double bond here. So two possibilities are there. These two methyl group, they are outwards. Very important. That means when you consider the HOMO of 1,3-butadiene, two type of rotation it is possible. Either you can get this part or you can get this part. Both inward or both outward. Both possibilities are there. So now let's get back to the question. So only option C, we have both the groups inward, and option B, both the groups outward, which is the correct one. So option C or option B, at the moment they may be correct. Option A, this part, and option D, they are wrong choice because it shows outward inward, outward inward. Both it should be inward inward or outward outward. So A can be B, this option B, this one or this one. Now the correct choice will depend on the product B. How the product B looks, that will be important. In the previous videos I have mentioned that since this is a diene, both are diene, and there is a dienophile here, it will give me Diels Alder reaction. Diels Alder reaction. Since this group it is bulky, it will favor endo product. Endo product means this will be down. Okay, this will be down. So here it is down. Why it is down? Because the H group over here, it is shown above. In this part also the same stereochemistry it is observed. This part it is down, H group it is on top. Now what is the difference here? Only this part, this is shown upward, this is shown downward, this is shown downward, this is shown downward. So your answer will depend on the stereochemistry of this part only. The stereochemistry of this part. Now let's get back to this board, and remember, whenever we have a diene and we have a dienophile, okay, we have a alkene group, when it gives the Diels Alder reaction, I'm just taking for reference purpose, when it gives the Diels Alder reaction, always remember the inward group, it is always shown above the plane of the paper. Just remember the stereochemistry, the inward groups are always shown above the plane of the paper, and the outward group, it will, once it reacts with an alkene, the outward groups, they are always shown with the dotted lines or below the plane of the paper. So let's get back to the question. Here we are having outward group. Here we are having outward group, means the stereochemistry here, it should be down the plane of the paper, below the plane of the paper. So this is the correct choice, because the outward group, it should be shown below the plane of the paper. Now what about option C? What happened here? Both the groups are inward. Inward means the stereochemistry over here should be above the plane of the paper. Here it is above the plane of the paper. Yes, it is correct. But here it is shown below the plane of the paper. So due to this wrong stereochemistry, option C is not the correct choice, but option B is the correct choice.